So far what we have seen is feature selection using inferential statistics, or we also call it as univariate selection. So in univariate selection, what we have done is we have used statistical significance tests to do the feature selection. So what all statistical significance tests that we have used? One is z-test, t-test, chi-square test, and ANOVA or f-test. And these are the tests that we have worked on to do univariate selection. And of course, these are applicable to different types of variables or levels of measurement. So now we will be moving on to the other methods. Here other methods is nothing but we will be doing feature selection using feature selection algorithms. So there are primarily three types of feature selection algorithms. One is filter type feature selection, and a wrapper type feature selection, and embedded type feature selection. So these all algorithms we will be understanding, and then we will be working on with one example. So let's do a feature engineering. In the feature engineering, we will be doing the feature selection using feature selection algorithms. So let's unravel the feature selection algorithm. So there are fundamentally three types of feature selection algorithms. So feature selection. So what is a feature selection? Feature selection is the process of selecting a subset of relevant features. Here features are nothing but variables or attributes from a larger set of available features in a data set. It aims to identify the most informative and discriminative features that contribute the most to the predictive performance of a machine learning model. So by selecting a smaller subset of features, feature selection can improve model efficiency, reduce overfitting, and enhance interpretability. So let's look into the first type of feature selection algorithms. So the first type is filter type feature selection. Filter type feature selection algorithms assess the relevance of features based on their individual characteristics, independent of any specific machine learning algorithm. So these algorithms evaluate each feature individually and assign a score or rank to measure its importance. So features are then selected or discarded based on these scores or rankings. So filter type algorithms are computationally efficient and applicable can be applied as a pre-processing step before applying any machine learning model. So let's look into the examples of filter type feature selection algorithms, or else different types of feature selection algorithms that we have under filter type feature selection. So filter type feature selection algorithms include variance threshold method. So variance threshold method removes low variance features that have little or no predictive power. And how do we use this method? We can use sklearn library and feature selection package and import variance threshold module. So next we have a chi-square test. Again, chi-square test measures the independence between each feature and the target variable for classification problems. It's specific to the classification problems. Same, we can use sklearn and feature selection. We can import chi-square. Then we have information gain. So information gain measures the amount of information each feature contributes to the target variable for classification problems. And same sklearn selection from feature selection import mutual info classif, and this is what is information gain. So this is for the classification problems. If you want it for the regression problems, we have to call it mutual info regression. Okay, these are the two types of uh, information gain modules can be imported from a sklearn library. Then we have the fourth one. This is correlation based feature selection. So correlation based feature selection measures the linear relationship between features and the target variable or between the features themselves. So how do we get it? Of course, we can use again sklearn feature selection import select k-best. We call it as a select k-best, and this is what we use. So these are the libraries that provide filter type feature selection algorithms include scikit-learn, of course, select k-best, select percentiles or feature selector or scipy, many more. Okay, so then the second type that we have here is okay, so the second type that we have here is wrapper type feature selection. So wrapper type feature selection is nothing but for wrapper type feature selection algorithms assess the relevance of features by training and evaluating a specific machine learning algorithm. So these algorithms create multiple subsets of features and train the machine learning model on each subset. So the performance of the model on each subset is used to determine the relevance of the features. So wrapper type algorithms typically involve a more exhaustive search of the feature space and can be computationally expensive. So let's take some of the algorithms which comes under wrapper type feature selection method. So the first one is recursive feature elimination, RFE, which is very important. So recursive feature elimination, RFE, iteratively removes less important features based on the weights or coefficients of a machine learning model. So how do we import this? So from sklearn feature selection import RFE, and we can also use this. Okay, next we have forward selection method. So forward selection starts with an empty set of features and adds the most relevant features one by one based on their impact on model performance. So obviously forward selection is not a built-in algorithm in scikit-learn, so we have to implement on our own. So we have to write a custom code, or we can take up external libraries. Any other libraries you can use, but here with scikit we do not have. So then we have the backward elimination. So backward elimination starts with all features and removes their least relevant features one by one based on their impact on model performance. So now let's move on to the third type of feature selection, which is embedded type feature selection. Embedded type feature selection algorithms incorporate the feature selection process as part of the machine learning algorithm itself. So these algorithms have built-in mechanisms or regularization techniques that automatically select relevant features during model training. So embedded type algorithms combine feature selection and model training into a unified process which can lead to a more efficient and accurate models. So some of the examples of embedded type feature selection algorithms include a lasso. So lasso is nothing but uh, least absolute shrinkage and selection operator. So this adds a penalty term to the loss function encouraging sparsity and automatically selecting relevant features. So how do we call up? So again, sklearn, linear model, and import lasso. Then we have ridge regression. So ridge regression uses L2 regularization to shrink the coefficients of less relevant features towards zero. And how do we call this? Using sklearn, linear model, import ridge. Okay. And the last one, elastic net. Elastic net combines L1 and L2 regularization to balance sparsity and coefficient shrinkage. So libraries that provide embedded type feature selection algorithms include scikit-learn, uh, uh, GLM, NET, and Caret. These are other libraries where you can bring up. And similarly, for forward selection and backward selection, you can use external libraries other than sklearn also. And how do we call up the elastic net? So you can simply say sklearn.linear model import elastic net. So by understanding the different types of feature selection algorithms and their characteristics, data scientists can choose the most suitable approach based on the specific problem. So, dataset and machine learning requirements. It is often recommended to experiment with multiple algorithms and evaluate their performance to find the optimal subset of features for a given task.